Hello YouTube, today at powerjackrepair.org we got a motherboard that has a shortage. Basically we do fix shortages on the motherboard, but we ask all of our clients to send just the motherboard. Because sometimes, many times, we can't fix the motherboard. We can't find the shortage. Even if we can find the shortage, sometimes it's those components that are, let me show you, something like that guy, or like this guy. We don't have those in stock, or this guy. We don't carry any junk motherboards in stock to transport the chips like that from one motherboard to another motherboard. Alright, so as it says on the website, please text us instead of calling us, because sometimes we record the video, not sometimes we got 1,000+ videos on our channel. So the thing is, when the client sends us just the motherboard, sometimes we can find the shortages, but the only shortages that we're gonna fix are shortages related to those yellow capacitors. That's the most common type of shortage, are those yellow capacitors. Basically brick, not yellow, maybe a bit brownish top, but the guys that look like that. Sorry, wrong one. Here. This camera right here. Yeah. So bricks like those guys right here, they fail all the time. And what we can do is we can just simply remove one of those and send it on its way. We do have replacement capacitors like that. Sometimes we install them, sometimes we don't install them. Again, it's as long as we can find which capacitor is shorting the motherboard. Basically, the shortage is on the motherboard is when you plug in your power supply and the light on the power supply goes out. So the light on the power supply goes out, that means you get a shortage on the motherboard. Could be one of those, could be one of those, could be something like that guy. Or if it's a CPU or a GPU, we don't even deal with that, simply because the amount of time it takes to properly replace this guy or that guy, you're not gonna pay for it, because we allocated in the United States. Maybe someplace overseas somebody could pay somebody to replace this guy or that guy, but here in USA nobody does that kind of I mean, we can do it, but the amount of time it takes, and then you can't really warranty it that well. I mean, you could, but again, we could find dozens of shortages before, instead of replacing one of the CPU or GPUs. And overall, our business are the jack replacements. But many times when you get the laptop for the jack replacement, it has nothing to do with the jack. It has to do with the shortage on the motherboard. In this case, I already looked at it. I already kind of know where the shortage is at, but I would like to show you that how it works. So let me show you. So we take the motherboard right here, and we're gonna do a voltage injection. What we do is we connect a compatible plug. This is 2.5 by 5.5 plug. We put it into the jack. The next thing, we connect the red wire from the power supply and the black wire from the power supply to the negative, and red one to the positive end. Then we have a power supply that doesn't interrupt electricity if it encounters a short. Instead, it keeps pushing the electricity into the motherboard regardless if it encounters a short or not. A regular power supply like the one you use on your computer, it will stop as soon as it encounters a shortage. It's a fail-safe in the power supply, but this is a special power supply. I mean, any power supply that provides a constant electricity. Let me move all of that stuff this way so you could see everything better. Now, we went through dozens of those power supplies, and we find that this one has the best interface overall, because we got two on-off buttons. On the first on-off button, we can regulate which voltage we want to send to the motherboard. On the second output, we can power off and power on the voltage in without shutting down the whole thing. And we can adjust the voltage and amperage. Now, for this particular motherboard, I couldn't find the shortage for a long time, because we usually use 5 volts and 1 amp to find the shortage, and at 5 voltage and 1 amp, nothing showed up. Once I boosted up the output towards the 19 volts, let me show you how it's going to be done. So we got an on-off button right here. Here we set 19 volts right here for the output instead of 5 volts. And we set 1 amp for the 1.1 amp, as it shows right here. You could probably see it right there. All right, so like that. And now what we're gonna do is we're gonna power up the whole thing. And we have a thermal camera that I ended up buying from one of people on the West Coast that advertises those. But the camera is garbage, so eventually I will invest into some other camera. We have a thermal camera that's a different one that attaches to the cell phone, and it has a much better resolution than this thing. But this is good enough for me to see where the shortage is at. So let me switch it to the thermal camera mode, because the other camera that we use, the thermal camera that is much more precise, doesn't have the interface to be connected to the computer, and you're not able to see anything on the screen. That was the biggest complaint, that when I'm showing you how I'm using that in order to find the shortage, you guys basically tell me that I need something to display on the screen. So here we're going to display something on the screen. So this, that's not the right one. Yeah, right here. So this is the view from that cheap, no, it's not cheap, it's actually $300, I think I paid for this thermal camera. And basically when I rotate it like that, you can basically see what the problem is, but I will point it like that, all right? And what I'm gonna do is I'm gonna power up the output right here, press the output button, so we're gonna get 19 volts into the motherboard continuously without interruptions. And we're gonna be able to see on the camera what's going on. All right, so let's switch to the, okay, so let me, you know what, let's switch to the thermal camera, and now we're pressing the output button. All right, we press the output button, and you could see right away we get flashes. All right, you see the flashes? Let me do a better flashing. That's the connector in the middle. And we get a flash to the right of the connector, and we get a flash a little bit to the rear left of the connector. Now that's a lot. Again, this camera is a pure garbage, but at least I can show you what's heating up. Oh, wow. We get a CPU heating up as well? Or is it just a reflection? All right, so let's move the whole thing outwards. And you could see the flashes right here. You see this flash and that flash. This flash. Do you get any flashes anywhere else? Well, that's just a ground. It's nothing special. All right, so this is how we look for the shortages. All right, so we know that we got one flash right there and we got one flash right here. Let's switch back to the non-camera mode. Let's shut it down. Let's shut down the flare. Or should we shut down? Yeah, we should shut down the flare. Let's shut down the power supply, and let's turn off the power supply altogether. Let's unplug this guy. All right, so the flashes were to the right of the jack. It was the MOSFET. This is called MOSFET. Could be this one, could be that one, I don't remember which one. But MOSFETs usually, they do fail sometimes, but not really the problem. I mean, sometimes people take them off and then they still can't find the problem, because MOSFET, sometimes we could test them and see, but the second flash was somewhere right here on the left side. We got 1, 2, 3, 4, 5. We got 5 capacitors right here. So it's not all 5 of them that are faulty. I mean, if we measure the continuity between the 2 capacitors, for example, right here, we get a shortage. Here we get a shortage. And here we get a shortage, and here we get a shortage. 0, you see, we got 0. That means that all of them are shorting. But it's not that all of them are shorting, it's just one of them is shorting. And the one that's shorting is flashing up right here. So if we're gonna find which one of those 1, 2, 3, 4, 5 guys right here is shorting, here, let me switch to this camera right here. So again, it's either the, again, those guys usually never fail, all right? We do have replacements for those, but even if we replace them, sometimes it's usually just has to do with the capacitor someplace. So, and again, listen, before sending us the motherboard for the shortage repair, email us, because of the 2019, 2021, 2022, everyone became wealthy and I can't find employees at this time, so I don't really have time for shortages. They take time. So, and for now, send us just the motherboards, not the whole laptops, because again, I have the business is basically power jack replacements, because I could replace the jack, put the new one in, and it's gonna work fine. When it comes to the shortages, I have to spend time troubleshooting. So here I'm troubleshooting already 10 minutes, well, more than that, but anyways. So we are looking at this area right here, and we're looking at this area right here. I don't see those guys to be miscolored in any way, shape or form. So we have to see on those guys. So the first thing I'm gonna do is I'm gonna power up my microscope. And the microscope is, I paid $1,000+ for it, and it's a special one. And it's a special one because sometimes it helps me figure out which one has the issue before I even gonna... But here visually I can't see any damage to anything. But I understand that the area is right here, and I understand if I remove all 5 of those, the laptop might be working. But instead of removing all 5, let me first do a visual inspection. Alrighty. Do we have a recording? Okay, seems like everybody's in focus. And from microscope, we can pretty much see right away. Okay, so if it's gonna be extremely bright, like that, we're probably not gonna be able to see much. But if we go down a little bit in brightness, again, the reason that this microscope costs $1,000, I can already see the problem. And I think you can see the problem too. Let me get it as dim as possible. And right now you can definitely see a problem. And the problem here, you could see on the microscope, is this guy right here. Seems to be having some sort of miscolorations right here. All right. This guy looks good right here. Like all of them look good, except this guy. And I think it should not be going like that. I mean, but the reason I paid $1,000 for it, so we could do a 3D visual inspection. Let's switch to 3D visual inspection. And we're gonna add a little bit more brightness. And we're gonna rotate it 3D, and you could see this thing. Right here, you see? This doesn't look right. All right. And that's the reason I paid $1,000 for this microscope, so I could inspect the areas before I'm gonna just take all of them off. So something definitely isn't right with this guy. So let's try and take it off the motherboard and see if it's gonna improve this situation. Alrighty, I installed the second exhaust fan outside of the building, so you could hear me better. Hopefully you can hear me much better than before. What I want to do first, I want to add some flux right here, and right there. Okay. Then what we want to do is add some solder. And today we're gonna test a new, well, it's not so much test, I already used it many times. I want to see how well. What we're gonna do is we're gonna add some solder here and here. All right. And then what we're gonna do is we'll try to take this guy off the motherboard using just the tweezers. The tweezers alone are $340. Those are micro tweezers. And I'm not sure how well they're gonna be able to take this guy off. They're not taking off anything yet. The station for the micro tweezers is another $300. I usually use it for installing the new components, but here the motherboard is probably absorbing all the heat. Okay, like that. So after a while, I was able to get this guy out of here. All right. So let's see what we can do there. How does it look? All right, it looks like we get a bridge right here to the nearby component, which we don't want to breach anything here. Let's do something like that. Oh, the tweezer's already not straight. All right, let's clean up the tweezers and let's thin them. All right, and let's set the tweezers aside. Alrighty, let's see. Let's measure the continuity on the capacitors at this time. All right, so the way how we measure continuity is like that. Let's see. Oh, this thing doesn't work. Okay. Oh no, it does work. Here. This one? Yeah, looks like that's the one. All right, so we set the voltmeter here, and we test the nearby components, and we don't have anything yet. Hold on. Let me see this guy. Hold on. Let me figure this guy out. Okay, like that. Let's see. All right. And we don't have a shortage anymore on the capacitors nearby. Yep, and we are good. Now let me go see if I could find another capacitor like the one I took off. I have them someplace, but the amount of time it takes me to find it is gonna be probably more than I'm gonna make on this repair. So hold on one second. All right, guys, I apologize. I spent about 20 minutes looking for the capacitor book, and you should understand there is more than one workstation here, and it could be in the garage, could be in the basement, could be at one of the first floor or the second floor, and could be under one of those gloves pile. But yeah, I wanted to make a super nice video like how smoothly I fixed those capacitors, and wanted to show you how the tweezers can put the new capacitor in place. But I guess I will have to do it later, set it aside, because I got a whole bunch of other work to do. And what's gonna happen here is let me show you that it's all gonna work well. The reason it works because we don't have a zero resistance anymore on top across the board here. So you see, we get resistance here, we get resistance there, and we get resistance here, here. So we're good. We're good. So now if we connect the power supply here, if you power up the floor station, that thing should not be lighting up anymore. And the floor station, being a Chinese stuff, doesn't want to power up. And I didn't shut it down. So maybe I need to reset it somehow. Well, you see all this Chinese stuff and not being able to show you the final result. Come on. Yeah, probably the battery died while I was talking to you guys. And the battery charger is a different charger. It's not this charger. All right, let's do this. Let's do that. Okay, let's connect it. See if we're still gonna get the image. So yeah, you know, repair place, but nothing works. So what I was able to do in addition was to add some solder to the back of the connector. You see the rear pin right there on the top side and on the bottom side, because those soldering points sometimes get not a good connection. All right, I'm not sure when I press the pause, but here I wanted to show you that we do get voltage all the way at the battery. Come on, let's power it up. Come on. All right, let's power up. And we switch it to 10 volts here. We do the output. Well, output's not gonna be done. We're gonna plug that guy in. We're gonna do the output. And here we should get 3 volts right there. You see, we get 3 volts. That means there is no shortage. The current goes all the way to the battery. All right. All right, thanks for watching. Again, I'm sorry I didn't show how I'm soldering a new capacitor in place. Maybe some other video, but again, too much work to show, to spend more time on this video. Please leave a thumbs up and subscribe. And if you have exactly the same problem, the cost to repair this one was $60. Well, to find the shortage and remove the faulty capacitor is $60. So yeah, thanks so much. Have a good day. And again, I do have a book capacitors. I will set it aside so it would be someplace nearby in the future, but it just happens that it just disappeared. All right, so yeah, thank you.